Bom, eu acho que então eu vou começar. Tudo bem? Tá bem, então, gente. Bom, bem-vindos de volta para mais um Efígie Mock Class. Essa aqui é a nossa terceira Mock Class na trilha de Health and Science. E hoje, na verdade, a gente está tendo, assim, uma Mock Class que eu acho, pelo menos, muito legal, que é de ciência forense. A professora que está aqui com a gente é a doutora Kimberly Nugent, do West Coast Connection, em colaboração com Ontario Tech University, de Forensic Sciences, e ela vai falar um pouquinho para a gente sobre o curso dela e como todos vocês podem entrar agora em ciências forenses. A professora também vai pedir que todos nós participemos da aula por meio de algumas perguntas. Só entrar nesse site aqui que a gente está mandando o link agora. É só colocar o nome de vocês e só. E daí vocês vão conseguir fazer parte. Também não esquece que para todo mundo que fez 3 mock classes dessa trilha ou mais, concorre a prêmio. E também não esquece de seguir a gente no Instagram e no Telegram. A gente também faz pelo Insta sorteio de prêmios e também um monte de informações sobre diferentes faculdades e sobre eventos da Efígie e também os calendários das mock classes. Então, acho que eu falo por todos quando eu agradeço a professora Kimberly por estar aqui, por estar apresentando para a gente. So, Dr. Kimberly, thank you so much for joining us today. If you'd like to begin.
Great. Well, thank you so much for having me. So thank you for the introductions, and I can see students already signing up to Nearpod. So that is fantastic. It allows for a little bit more interaction if you want to interact. So let me share my screen. And I hope everyone is doing fantastic today. If the moderators could maybe just let me know that my screen is sharing appropriately.
Yes, Dr.
Yes.
Kimberly, we can see it.
Perfect. Thanks so much. Okay, so let's get started. So as I was introduced, I'm actually from Ontario Tech University. I'm an associate teaching professor there in our accredited forensic science program. Now, Ontario Tech University is located near Toronto, Canada, for those of you familiar with North America and Canadian geography. I've probably been teaching over 20 years now, the last 15 of which were at Ontario Tech University. And I came there to basically start up our forensic science program in collaboration with other faculty members. So it's been exciting. We have some great facilities. We have a crime scene house, which allows our students to actually apply the theory that we teach them in class. So it's a very technology focused, experiential learning type of university. And in my spare time, I'm also the president of the Canadian Society of Forensic Science. So this is our professional organization in Canada that provides oversight and engages the forensic science community. Some fun facts about Canada. I was actually looking up this earlier today, and I did not know that Canada has the world's smallest jail. And there's a picture of it right there on the top right corner. It's located not far from Toronto, and it's about 24 square meters, so really, really tiny. Other fun facts about Canada, more than half of the lakes in the world are located in Canada, and half of the country is covered by forest. It's a beautiful country, and I'm glad to call it home. And more near and close to our heart, Toronto is actually one of Canada's largest cities and is known for being very multicultural. So we see the benefit of that at Ontario Tech University. So we're here to talk about forensic science. So let's chat about forensics. But before we talk about what forensics is, let's talk a little bit about what forensic science is not. So for those of us who don't spend our days following the trails of serial killers or decoding evidence in the lab, we get all of our crime solving knowledge from pop culture. So books, TV, movies, and there's no harm in that. It's fun, right? It's fun to watch. I'm binging Criminal Minds right now, but as long as you don't believe everything you see. So one of the first myths is that actually solving crimes takes a long time. In reality, most crime work takes several months, even years in some cases, to be solved, if they're ever solved at all. So lab work especially is very time consuming. DNA testing, as an example, that can take at least, if your schedule is clear, from 2 to 5 days. And that's a best case scenario. Sometimes it can take months, 1 to 3 months total from start to finish before you even start looking at the evidence. You've just ran your samples. Another misconception is that the same people don't do all the work. So they don't also collect the evidence and analyze the evidence. So law enforcement officers, those individuals that go to the field and to the crime scenes, they have the training to document and collect evidence. They don't necessarily do the laboratory analyses. They send that material, that evidence, to the lab. So an expert can actually run the samples, use the proper instrumentation to make those examinations. There's lots of paperwork. So in real crime labs, one of the major differences I see on TV is procedural. So you can see detectives or scientists walking from one room to the next, kind of chatting with different people, doing different things with the investigation. And then they check back in a day or two and it's all done and solved. Doesn't usually work that way. Usually people work in distinct buildings, probably not near one another. And in reality, these individuals communicate through formal reports, including paperwork to request information for different tests, information, etc., reports. Database matches, that's another misconception I've seen on TV. So databases usually return. So this is where you're going to see the fancy fingerprint matching software or DNA database hits on TV like CSI. So usually databases will return multiple hits, but unlike what you see on TV, where you're actually going to get a ping and almost immediately it's like, whoa, these two match. It actually takes quite a long time, and a match will return several results that an individual, an expert, then needs to sort through and then identify, make those comparisons in person. So it's not actually the computer doing the work, they're just narrowing down the search for the individual to then do the hard work. It's really just the beginning of the investigation at that point. Okay, so my question to you, I told you what forensic science is not. Now I'd like you to tell me what you think forensic science is. So what is forensic science? You've probably seen a TV show, you've watched a movie that has elements of forensic science. You've read some popular books. Kathy Reichs was probably one of the first to popularize forensic science in paperback. So what are your thoughts? And don't be shy. So solving crimes. What else do we have? And then I'll kind of go through them. Analyzing evidence, very much so. Using science to interpret evidence. Analyzing evidence to reach conclusions. Very good. You guys are on the right track. I'm impressed. Or you've watched a lot of CSI. So that's exactly it. Forensic science is very much the application of science to matters of law. What kind of science? it can actually be any kind of science. Forensic science is actually rooted in core disciplines like chemistry, biology, physics. But nowadays, any application of science as it's applied to courts of law can be deemed a forensic science. There's such thing as forensic engineers that look at the structural integrity of buildings or bridges. There are forensic nurses that unfortunately deal with a lot of sexual assault cases, forensic accountants, audit trails, money laundering, forensic psychologists, which deal more with the social science aspect of forensic science, but it's all encompassing. The application of science disciplines to a field of law. Now, the word forensic actually comes from the Latin term forensis, which basically means in front of the courts or in of or before the forum. So back in Roman times, if a criminal charge was brought against someone, then they would assemble in the forum, and that's when each person would then plead their case, and whoever pled it the best, whoever made the best argument, they would win. So it had nothing to do with the evidence back then, but that's where the word forensic comes from. Okay, so one of the things, this is very much an overview lecture to hopefully teach you a little bit more about forensic science and maybe spark your interest in pursuing this as a career. Important to know, and if I leave you with anything today, what I want you to know is that forensic science is very much a team effort. It's very multidisciplinary from every aspect of the crime scene to the courtroom. There are multiple departments and individuals with different levels of expertise and knowledge who specialize in collecting evidence, analyzing the evidence, just to name a few things that are done. So I'm going to actually go through these in a little bit more detail just to elucidate to you what's involved at the different steps of an investigation. So first we start with more than likely the crime scene, right? So this is where a forensic scientist, and this can vary a little bit. So I'm making a few generalities and maybe relating it back to what I know from here in Canada. But there's different variations of who does what with regards to the crime scene, the laboratory, the experts, depending on jurisdiction and country. But for the most part, this holds true of everywhere. So at the crime scene, you have specialized personnel. In Canada, more often than not, these are the law enforcement individuals. They can be civilian or they can be sworn officers. These are the ones that go to the crime scene, they secure the crime scene, and they're the ones who document and collect. And that's probably one of the most important jobs, because if evidence isn't well preserved in the beginning, you're not going to make sense of it near the end of the investigation. God forbid it's contaminated. So these are the individuals that identify the important physical evidence, which can include any and all objects that establish that a crime has been committed, or you're trying to link a crime and victim, or victim and perpetrator. So this is where you're looking for clues, you're looking for evidence to make those associative links between the crime scene and the victim, or the victim and the suspect. So the forensic science investigation, it begins at the crime scene. And this is where the investigators must recognize, okay, what is evidence? What am I looking at? What should I touch? What should I not touch? And then properly preserve that evidence for later examination. And that proper preservation of evidence, that's known as chain of custody. So you want to make sure that you document the evidence well. And how do you go about documenting evidence? You're going to want to document a crime scene using photography, using sketches, using notes, audio and visual equipment. Those are all forms of documentation, and something being used a lot more now too are drones and 3D scanners to complement all those traditional documentation techniques to preserve a crime scene. After the crime scene is secure, the investigators go and record through those means that I just mentioned, and that's considered their preliminary investigation. They then identify what they want to collect in terms of evidence. This can be things like trace evidence, fiber from clothing, or hair, or blood. It doesn't matter. They identify what they want to collect. They then collect it in a best practices sort of way. So if you're collecting a hair sample, you're not going to want to put it in a big brown bag. You're going to want to make sure you properly preserve it in a smaller little box, seal it, label it, and then put it aside so it can be sent to the laboratory for analysis. So each item of physical evidence is collected at the crime scene. It's placed in its own appropriate separate containers, bags, whatever, to prevent damage, and more importantly, to prevent cross-contamination. You don't want to contaminate the scene with your hair, your fibers, your DNA, and vice versa. Any questions about the crime scene? As mentioned, if you have questions at any time, feel free to ask. Okay, so once all the evidence is collected from the crime scene, law enforcement individuals, forensic identification assistants, scene of crime officers, those are all terms used to identify those individuals collecting evidence from the crime scene. Some of them might do some preliminary laboratory analyses. They might do some audiovisual examinations. They might do fingerprint comparisons, some presumptive DNA testing, just to rule out some investigative leads. All other types of evidence go to the laboratory. These can be, depending on your jurisdiction, your country, either government run or private laboratory facilities. And this is where you have the forensic scientists who have scientific backgrounds in a specific discipline, a forensic biologist, a forensic chemist, and they're skilled in applying the principles and techniques of the physical and natural sciences, so theoretical, to the analysis of that specific types of evidence that was recovered at the scene. So examinations in the lab are performed in order to identify a material in question, or to determine if it could have originated from a particular source. So where did this come from? Can you link the victim to the crime scene, or the perpetrator, the suspect, to the crime scene? So these are very much useful as investigative aids, as leads, in cases maybe when there's no suspect that has yet to be identified, or you're trying to associate a person with a particular location or a particular occurrence that happened. It can also maybe help in establishing a sequence of events. For example, in bloodstain pattern analysis, I don't know how many of you have seen Dexter, but being able to identify the characteristic bloodstain patterns that may occur on a surface will help you identify the height of the victim when they were hit, the height of the perpetrator, what type of weapon was used, as well as the sequence of events that might have led to the fatal blow. So let me ask you this, and hopefully I can open this up for a little bit of a discussion. Laboratory units, forensic labs are different depending on where you are, but some of the more common sections or units within a lab would be biology, toxicology, physical sciences, documents, firearms, and tool marks. So let me ask you this. What do you think the biology section, what would they analyze? What kind of evidence would come across their desk?
And Professor Kimberly,
Yes.
we have some questions in the chat, so I think you can answer as students answer your question. So did you ask what kind of biological evidence?
Yeah, what would be considered a biological type of evidence? What would they see?
So Rogério asked about the role of civilians in the collecting evidence. And also Alessandro is asking that it's true that if UV lights can reveal blood marks?
Oh, those are great questions. Okay, and this is what's going to make this lecture interesting, because now we're going to go on tangents and we're going to start talking about different things. So civilians, yes. Again, I'm going to relate it back to my experience here in Canada. Traditionally, a lot of the scene work used to be done by those individuals who were sworn officers, known as scene of crime officers. Now, slowly, that responsibility is shifting to both obviously sworn officers, but also now civilians who are known in some cases as forensic identification assistants. So there are opportunities to work in the field of forensic science and actually go to the crime scenes as a civilian, which was not always the case. Now, I know in the States, they've been using civilian individuals as crime scene technologists for a lot longer. Hopefully that answers your question. Now, with regards to the techniques used at a crime scene, this is where it gets interesting. I'm just giving you a flavor of different things in forensic science. The fact that you brought up laser lights, alternate light sources, I can do a whole 3-hour lecture just on that. So if this is something you're interested in, forensic science has a wealth of interesting material that you can dive into depending on your interest. But yes, to answer your question, they do use alternate light sources, which use different wavelengths of light to illuminate, for lack of a better word, to illuminate different types of evidence at a crime scene. So biological material will fluoresce under a certain wavelength of light, as would perhaps a hair. You can use this to search a crime scene for evidence you might have missed. Also, sprays like luminol or blue star will help you detect or observe suspected cleanups where blood might have been. So more than, and I didn't touch on this, but more than just collecting and documenting evidence at a crime scene, you're also doing some preliminary analyses to rule out what is potential evidence and what isn't. And that's through the use of these chemical sprays or alternate light sources. Now, with regards, oh, sorry, yep.
Thank you, Kimberly. We have also some answer to your question in the chat. So Marina Leal said fingerprints. Melka mentioned blood, hair, nails. Luisa, for example, if it's a sexual crime, the sperm. Rogério said anything related to the human body of someone involving the crime. Giovanna said hair, sperm, DNA. Alessandro also said any form of DNA, I can imagine.
Perfect. Yeah, those are great, guys. So definitely the biology section of a laboratory, they're going to deal primarily with bodily fluids. Those can be on a number of substrates, so clothing as an example. So blood, semen, saliva, and on those, they're going to perform different tests, the most common being DNA profiling. And usually, a lot of these types of evidence are seen usually of crimes against persons, of people and property. So a lot of break and enter cases, sexual assaults, and homicides, unfortunately. Okay, some of the other units that are common in different forensic labs would be the chemistry unit or perhaps the physical sciences unit. Now, the chemistry unit, they would provide chemical analysis and physical comparisons of many different types of materials. So they could do chemical identification and comparisons. They could identify inks and dyes. They could also look at fire and explosive residues. They're going to look at fire, a lot of trace evidence like fire, glass, hair. They're going to look at firearms and gunshot residue if there's not a specific firearm section, and different things like that. In some cases, there's a document section. Here in Canada, we actually have a whole forensic document investigative unit that's housed within the Canadian Border Service Agency. So it's not necessarily housed within a forensic public government facility that's a forensic facility. It's tied in with the Canadian Border Service Agency. But what they look at would be document examination, looking at question documents, suspect documents to ascertain authenticity and or source. So they're going to analyze papers and inks, indented writing, obliterations, erasures, even burned or charred documents. So that's pretty interesting. And I mentioned firearms and of course toxicology. I don't want to forget that. That's another big unit usually found in a forensic laboratory. And they're going to take a look at tissue samples, fluids, and they're looking for the presence of drugs, including alcohol. And this supports the forensic investigation. As it relates to certain cases involving, for example, impaired driving, homicide, and sexual assaults. Okay, so we have the crime scene. Then you have some of the analyses, examinations that happen at the scene. What doesn't happen there goes to the laboratories and their forensic units, biology, chemistry, toxicology. Then in some cases, you need to call upon discipline experts that are usually found in academia who conduct a lot of research, but the day-to-day isn't processing a lot of evidence samples as they would in a forensic lab. So these are the less common types of cases where they would be called into. So these are the forensic science discipline experts available to law enforcement. They consult and they basically augment the services of the forensic crime lab. So an example of this would be an anthropologist who studies bones. So you're not necessarily going to get bones into a forensic lab every single day, but when you do, you're going to want to call in a discipline expert to help with that in the investigation. Another example of a discipline expert, and I put on here, is a forensic odontologist. An odontologist is someone who studies teeth, uses dental records. They can use x-rays, casts, photographs of a person's teeth to compare to dental remains. So unfortunately, in mass disaster events, it is common for when nothing else remains, there may be some dental remains of a suspected victim, and then that can be compared to photographs or x-rays taken of the victim when they were alive. So it's that comparison that a forensic odontologist would do. So something else a forensic odontologist may or may not do let me ask you this, do you think a forensic odontologist would be able to compare bite marks left on the victim to the tooth structure, to the tooth pattern, to the teeth of a suspect? What do you guys think? Feel free to put it in the chat, or you can respond on Nearpod, whatever you think is best. Cool, good job, guys. Yeah, they can actually. Now, that being said, it's not without some controversy in the forensic sciences, and it is up for debate on the validity of being able to make that comparison for a variety of reasons. But there has been research and there has been expert witness testimony on the use of bite marks. So comparing bite marks found on a victim to that of a suspect. So yes, it does fall within their purview of forensic odontologists to make those determinations. Okay, and finally, we finally get to the courtroom. So after a year, not an hour, but a good year of going to the crime scene, analyzing all the evidence, and then calling in the experts and going back and forth with paperwork, the case goes to court. And in court, the forensic scientist, whether you're the law enforcement or civilian at the scene or the forensic scientist in the laboratory, you might be called as an expert witness. So an expert witness is an individual whom the court calls to determine because they possess this specialized knowledge relevant to the case at hand. Specialized knowledge that your average person does not have. They're there to evaluate the evidence based on their specialized training and expertise, something the court doesn't have. So let me ask you this. Another question, another poll. An expert witness, are they allowed to provide their personal opinion to the court? What do you think? Oh, I think I tricked you guys here. Now I can't see what you put in the chat, but what I'm seeing in the polling is a lot of people said false. And the answer is actually true. While a layperson, so you and I, for example, if we're called in to provide testimony on what we saw, we can't really rely on our personal knowledge. We don't have that depth of experience and expertise. So our opinion is really frowned upon. But an expert witness is actually called into court to provide their opinion as to the significance of the findings. So that's a difference between those. Okay, so let me continue. So I kind of gave an overview of crime scene to courtroom, just to give you a taste of the different players involved in a forensic investigation. Now I'd like to maybe just focus on a specific aspect of forensic science, and not in any great depth, but just to give you a taste of death investigation. So a death investigation occurs when a coroner or medical examiner seeks to understand why someone dies. And this information can help prevent other deaths under similar circumstances. And they seek to find out 5 things. They want to understand who the individual is that died. They want to understand how the death occurred, when the death occurred, and by what means. So that's what we're trying to figure out with any death investigation. So I'm going to share a little video with you just to kind of set the stage, and then we're going to keep talking about what is entailed in a death investigation. And hopefully you can hear that. I'm sharing my sound.
Death sucks. But what happens to your body after you die is fascinating. So we're going to show you. Don't worry, it won't be gross. Much. Once a person's breathing stops, the cells in their body stop receiving oxygen, but the cells continue to live for several minutes, generating carbon dioxide. Carbon dioxide is acidic, and it builds up, rupturing sacs inside the cells. These sacs contain enzymes that begin to digest the cells from the inside out. This creates a blister-like fluid rich in nutrients. After about a week, those nutrients fuel an army of bacteria and fungi that further liquefy organs and muscles. The microbes that attack the tissue produce a bewildering array of more than 400 chemicals and gases. They include freon, that's right, the coolant found in refrigerators, benzene, a powerful component in gasoline, sulfur, which smells of swamps and rotten eggs, and a molecule known as carbon tetrachloride, which was used in fire extinguishers and dry cleaning until scientists discovered it's highly toxic. At this point, there's very little flesh left, and it's consumed by, here it comes, maggots and beetles. The insects leave only bones behind. Over time, the protein in bone decomposes too, leaving just the bone mineral called hydroxyapatite, which eventually turns to dust. We can take some solace in the fact that all those nutrients and chemicals, even the dust, provide vital substances that make soils fertile, sprouting plants and other new life after our lives have ended. Ashes to ashes, dust to dust.
So I'm going to touch on some of the stuff that was just mentioned in that video, but that's a great recap for the decomposition process. And if you're at all interested in the forensic sciences, whether it be the field work or the laboratory work, just know there's a plethora of disciplines to trying to research best practices in the discipline. So for example, those chemicals that are being released from the body are called volatile organic compounds. And there are people doing research on those specific compounds and how to best identify them after death. How long do they last in and around the body? There are individuals that do research on the insects and their successions when they come to a body and trying to determine how long a body or victim has been there. So just fascinating that many different worlds that fall into forensic science. But let me take a step back. We're talking about death investigation, but the determination of death has never really been straightforward. Things like alcohol, drugs, different infections, they can really affect one's metabolism and physiology, and they can maybe make an individual weak, their respiration and pulse rate really low, for them to appear dead, but they're not dead. So you can imagine a time before medical science as we know it today. What did they do if they didn't know someone was dead? Signs of life can be, back then, I'm talking about 1800s, might have been difficult to accurately interpret. One of the methods that they used to use, I don't know if you know this or not, when a person died, what they created were waiting mortuaries. So the suspected dead were placed on cots and then watched. They were placed on these beds and then watched until decay set in. Decay is that decomposition process. So although unpleasant, at least the family had peace of mind that the individual wasn't being buried alive, something that was not unheard of back then. So let me ask you this. What is the one thing that can be credited in changing how death was determined or confirmed in an individual? If we weren't too sure beforehand if an individual was dead, for a variety of reasons, what was this one invention that enabled physicians, doctors, to determine the presence or absence of a heartbeat? What do you think? What helped them make it easier to pronounce death and say for certain that someone was in fact dead?
So, sorry, Marina has vital signs.
And how do you detect the vital signs?
Rogério says an instrument that can detect heartbeats, a stethoscope.
Perfect. Yep. That's fantastic. So that's it. It was a stethoscope that was invented that enabled physicians to determine the presence or absence of a heartbeat. And then later, the development of the EKG, so the electrocardiogram, that was a device that records electrical activity of the heart, that followed soon thereafter. So the combination of these two devices really gave doctors and physicians a much more objective measure of death, so that they're not just watching individuals on cots waiting for death to set in. Okay, so fun fact. Now let's talk about the investigative process with regards to death. So the first part is very much certification. We want to identify who that individual is. How can you go about identifying an individual? That can be done many different ways. They could have identification on them already. They could have died in the presence of family members or friends who know the individual. Dental records, anthropology. There's ways of ruling out and identifying an individual. Again, that's a lecture for another time. Another aspect to the certification of death is attributing cause and manner of death. So what's the difference between these two things? Manner is the means by which the death occurred. It's a convention, it's not legally binding, but it's very much determined by the circumstances of the case. Now in Canada, in Ontario specifically, we have 5 conventions in with regards to determining or attributing manner of death. We have natural causes, just as it says, death that's due to a natural disease or a complication. You have accidental manner of death, death due to an accident or an injury. Suicide, death resulting from an intentional act or a very personal act. Homicide, death resulting from an intentional act at the hands of another. And then finally, undetermined, where you have conflicting or lack of evidence to be able to attribute the manner of death to one of the other categories. Now, cause of death, this is very much a process, a pathological process, injury, disease, which basically sets in motion the mechanism that gives rise to death. The final disease or injury that directly causes death. For example, a bullet wound to the head. Okay, that would be cause of death is a bullet wound. What would be the manner of death? It could have been a suicide if the individual did it to themselves, or it could have been a homicide. Okay, strangulation, manual or ligature strangulation, another cause of death, causing asphyxiation. The second part to the investigative process is the examination. So this is where samples will be collected from the body during autopsy. And this is when you're trying to determine the other kind of questions. Sorry, where you're going to try and determine the other type of questions about who that individual was, how did they die, who, what, when, where, and why. And these cases, sometimes other experts will be called in. Now, a pathologist or a coroner might be able to determine a little bit more about the timing of the death. One of the things that they can take a look at is the mortices. I don't know if you've learned about this, but mortis means of death. And an individual and a doctor, a pathologist can look at a body, and in an early stage of decomposition, the body will exhibit liver mortis, rigor mortis, or alga mortis under, variations to that, but for the most part, they will go through these, and it'll go through them at fixed times. So let me explain it in a little bit more detail. Liver mortis, this is when, so your heart ceases to function. It stops beating. As soon as your heart stops beating, blood stops circulating throughout the body, and then it settles. As soon as your blood settles, it's going to settle based on gravity, and it's going to settle in your capillaries, and it's going to start pooling. You're going to notice a loss of skin color, and this is going to be observed on the upper surfaces where the blood hasn't pooled. And this is because the lack of oxygen causes the change in color from that bright red to more of a deep purple as it collects and pools in the lower parts of the body. And then it starts to fix. Fixation usually sets in and around 6 hours. This is under research laboratory conditions, more or less 6 hours, but it can be affected with temperature and other variables. Important about this is it can be a sign of repositioning. So if the blood has pooled in a certain manner on the body, but it's not consistent with how that body victim was found, then it can be a sign that, perhaps maybe that individual has been moved, turned over, repositioned, something strange is going on, and you need to make sure that you corroborate that with any witness statement or other evidence found at the scene. Another mortis that a pathologist or medical doctor would investigate is rigor mortis. And this is because your blood stops pumping, oxygen stops flowing. What else starts being depleted is energy. So there's a loss of ATP in your muscles. And it's the smaller muscles that are going to lose that energy first. And what starts happening in a predictable amount of time, more or less in and around 12 hours, it becomes very rigid and fixed. And that's that pugilistic pose we see in that middle picture right there, where the individual is very stiff and their muscles have kind of stiffened in place and you're not able to move them anymore. Very much a chemical reaction. And then finally, algor mortis. This is hard to show this in a picture, but it's the cooling of the body to room temperature, very much dependent on the environment, the temperature of the room, etc., as is all the mortises. But it is something I wanted to show you because a pathologist, medical doctor investigating death would take a look at livor mortis, rigor mortis, and algor mortis to help try and attribute more or less a range of time since death. Another expert that might be called in to assist with a death investigation would be a forensic entomologist. And an entomologist investigates the succession pattern of arthropods, of insects, of blowflies, of beetles. So they understand their developmental stages and how different species found on decomposing body during an investigation, you might be able to work backwards and determine how long that individual might have been there. So flies, as an example, are very important scavengers. So they will come to a decomposing body because it's a source of food, it's nutrients. And that fly will then go through its complete life cycle feeding on that body, decomposing body. So a fly will be attracted to that nutrient source, to the food. It'll go there and lay its eggs. Those eggs will then develop into 3 different stages of maggots called larval instars. Probably takes about a day, more or less, to go through each of those. And then it'll pupate, which takes a number of days. And then it'll grow into a fly, become an adult fly. And then that cycle starts over again. So if an entomologist arrives at the scene, sees the body, and there are various stages of insects of development. So you have adult flies, you have maggots, you have pupae. An entomologist can then work backwards and assign a range of time to how long that individual might have been there. So that's pretty interesting. And there's also research being done with regards to insects and having ingested drugs and poison to help determine perhaps the location of an incidence or find the presence and time of the infliction of those wounds. And that's a discipline called entomotoxicology. So they're basically looking at the insects themselves having eaten the decomposing remains, and so looking for the presence of those drugs and poisons that were once in the victim. They're now found in the insect feeding off the body. And then another expert I'm going to talk about are the anthropologists. And the anthropologists will come in to help in an investigation. They're going to help put together a biological profile. So they're going to help determine the sex of the individual, male or female. They can determine stature. They can determine age. And this all helps develop a profile, especially in combination with if you have these time since death ranges. This all are all collaborative leads that work together to help the investigative process. So some of the things that an anthropologist will look for in the identification of these deceased individuals, they're going to take a look at the bones available to them. In determining sex, some of the bones that help the most in making those determinations are the skulls and human pelvises. So in males, for an example, they have very much a narrower heart-shaped pelvis, very much a narrower sciatic notch, and as compared to females where it's very much wider, and that's because it's the females that give birth. So that's one thing they're going to take a look at, and if they can identify that, then they've already created one part of a biological profile to help with the investigation. With regards to the skulls, male skulls are more robust. They have sharper, thicker protuberances around the eyelids. They have squarer jaws. If you touch behind your ear, there's a bone there, and it's called your mastoid process, and it's thicker. It's more pronounced in males. So those are some of the things that an anthropologist would look for. Another interesting thing an anthropologist might look at is trauma, and whether that trauma was inflicted on an individual before death or after death. So here in the picture on the left, we see an image of a skull with a hole through it. This hole is characteristic of a gunshot wound. So this is a bullet, a sharp projectile piercing through the skull. A characteristic of this type of trauma is the circular entrance wound, and then the beveling, a little bit of cracking in the exit wound as the projectile is exiting the skull area. So it's lost its momentum once it enters the front of the skull, and it exits the skull with a bit more shattering and causing a bit more trauma and fracturing. The middle image, I don't know if anyone has any guesses, but what do you think is happening with that bone? First of all, what bone is that? What's going on in that middle image? What do we see there? Do you think that's an arm bone? Is it a leg bone?
So Érico says it's a hip. Hip again from Luisa.
Okay. Your hip bone, well, your pelvis, but if you're thinking your leg bone, your femur, it's actually really, really big, your femur. That is actually an arm bone, and it's called your ulna. And your ulna doesn't usually look like that. Specifically, the middle part of the ulna isn't thick. So what happened here, I suspect, is that this person during their lifetime, they fractured their arm, they broke it. And what we see here is remodeling and the bone healing itself. And we know this didn't happen at the time of death. It didn't cause this person's death. And it certainly didn't happen after death because the bone had time to heal. So it happened during an individual's lifetime. And then finally, on that last image we see bone breakage, which is typical. Well, it could be attributed to a bit of blunt force trauma. We see 3 depressed cavities. Blunt force meaning something not sharp. So maybe a bat, maybe a hammer. Something sharp would be a knife creating puncture wounds, or a gunshot projectile from a bullet. So in this last image, we see 3 depressed cavities, which is indicative of blunt force trauma. We see cracking, depressions, and breakage, and it's not sharp edges in and around the depressed cavities. Oh, I'm sorry, I forgot to go ahead. So these are the 3 images that I were talking about here. So we see the gunshot wound with the beveling as it exits the skull. We see the middle image with signs of healing, and then the blunt force trauma with depression, cracking, sharp, broken edges. So this is something an anthropologist would look at to build their biological profile, determining the range of age, a range of stature, how tall the person was, their biological sex during their lifetime, any trauma inflicted ante-mortem, during death, or perhaps post-mortem. And then that in combination with the pathologist looking at a range of time attributable from the mortices, rigor mortis, algor mortis, liver mortis, and entomology. These are all the different disciplines that are coming together to help build the investigation. So let me ask you this. Little activity. So a statement was received from an individual. First responding officer came to the scene, and the officer, from the statement, it says that they found an individual outside, face down behind a garage. The suspect that found the victim said they were covered in leaves. They had to swat away all the flies that were on the victim, and then they immediately phoned the police because they were so startled. That image is from the autopsy report. So I'll take you a minute to look at that. I want you to tell me, is the witness lying? What do you think? He says he found the victim behind the garage, face down. They had to swat away all these flies. And then that's a picture from the autopsy. If you want to share it on the whiteboard, feel free, or you can share it in the chat room. Do you think this person was lying? Okay, Louisa, you said yes. Why do you think they were lying? The first to report always is. Well, that's very scientific, but there's something suspect, right? Discoloration is on the back. Good observation.
Yeah, so Rogério says he thinks the victim, the witness is lying. Erico says, is the witness lying? What do you think? Marina says, I think so.
Perfect. Okay, this is good. I love your answers. So yes, we're looking at blood pooling as one potential indicator that this individual was lying, because we see the pooling on the back. It's only going to pool there because of gravity if the individual died while on their back. But the victim says they were on their stomach face down. Something is suspect, and I think this requires further interrogation on the officer's part. So that's not bruising, it's actually the lividity. What else? Was there anything maybe about the flies? So it would be interesting to note, they said they had to swat away flies. Okay, that's all very well and good. Were there any maggots? The individual didn't mention any other maggots or any other types of insects. So that leads me to believe that it was early on. So it was very fresh. Decomposition had just kind of started happening. And if that's the case, that's when insects are newly attracted to the body. So they haven't had time to feed and reproduce and go through their developmental cycle. Perfect. Great job, guys. Well, we're almost out of time. Maybe I'll just skip ahead here. Okay, I'm going to skip ahead because I want to make sure I leave enough time for questions. And before I open it up to questions, I just want to let you know, forensic science, it's a really cool and fascinating field. If you want to learn more about what's happening in the world of forensic science, we actually have a conference coming up, the Canadian Society of Forensic Science, and it's at June 21st to June 24th. Lots of discipline experts, everything from blood spatter to footwear analysis to biological and chemical analyses in the laboratory. If you want to learn more, it's actually really affordable. Student non-members are $40, and that's for an entire week of networking, talks, posters, guest speakers. It's a great opportunity to learn more and see if forensic science is actually a career for you that you might enjoy. And there's my email address. So if you ever have any questions, feel free to contact me. But with the time that's left, I want to answer your questions. So please go ahead.
Okay, so I want to get the ball rolling. I'm going to open up my cam as well. I'm a very big fan of Dexter. I may or may not have dressed up as him for Halloween once. And I was wondering, what is the best movie or TV show depiction of forensic science?
Oh, goodness. Okay. That's actually a hard question because I don't watch a lot of those shows just because I spend my time debunking it. I never really got into CSI. I do love Criminal Minds, but I'm not a forensic psychologist, so I don't know how true and accurate that is. From what I've seen, I know Bones seems to be pretty accurate in that some of the stuff I touched on earlier with regards to myths, they have a team of people working on an investigation. So it's not just one or two people solving it and then solving it in an hour, right? So maybe okay. Bones.
Bones is great also, by the way. So Louise is asking, is it true that teeth don't burn in case someone tries to get away with a crime? If yes, why?
Oh, great question. No, I'm not a odontologist, so I'm not an expert, but under high temperatures, they might not burn, but you're going to start seeing cracking and a bit of disintegration. I mean, the bones are made up of very hard substances like dentin, keratin, calcium. So I might suppose that it might be because of that it doesn't burn so easily. But I would suspect under very, very high temperatures, they would succumb to the high temperatures of a fire.
Okay. Any more questions? You can put. Oh, okay. So Marina is asking, which books would you recommend for forensic psychology?
Oh, which books? An interesting thing about forensic psychology is I know the world of serial killers is fascinating, but forensic psychologists actually do a lot more than that. They're really involved with a lot of psychological assessments. So I have a slide here on that. So individuals who provide psychological assessments to the legal system. So they're really trying to determine competencies and evaluations of criminal defendants, counseling services. Yeah.
For a second, please. So everyone, Dr. Kimberly isn't presenting on Zoom, but if you go into Nearpod, she has the slide open for you guys. So just to mention, oh, she's. Okay.
Thanks for reminding me. I just took care of that. Yeah, it's hard to go between the two, but
Yeah.
just because I get asked, I prepared a slide on that. So psychology is not something I'm very much focused on the science of forensic science, but I know psychology is of interest to a lot of students. So there is a lot of opportunity for careers in psychology, but just know that a lot of it is with regards to psychological assessments as they pertain to the legal system, with some interesting career paths there for you to look at.
Okay. Are there any more questions? Okay, so Jessica asks, could someone act as a forensic scientist in a country different than the one they were born in? Like someone from Brazil to become a forensic scientist in Canada, for example?
Yeah, no, that's a great question for sure. A lot of our students have gone on to work in the UK as forensic scientists. They've gone on to work in the United States as forensic science, and the opportunities are there for you to come to Canada or you're the United States to work in a crime lab. It's completely up to you. There's no restrictions.
Okay, so Alessandro has his hand up. Would you like to ask a question, Alessandro?
Yeah. So is there a thing such as crime scene janitors? Like people that clean up crime scenes?
Oh yeah, they're actually, yeah, and I've read a few articles about individuals that do that and get paid really well because it's a very dangerous, right? And with regards to health and safety, it's a very dangerous job. You need to be well aware of the biosafety and hazardous materials that you're working with. But yes, it's definitely a job, quite profitable too.
And does dried blood serve as a form of DNA?
Yes, it does. Yes, you can definitely swab dried blood. You just have to moisten a swab just to wet it, and then yep, you're collecting DNA from that just as you would a liquid form of blood.
Okay, thank you.
Yeah, no problem. And a lot of research is being done with regards to aging blood stains. That's not something we've been able to do just yet.
So Louisa is asking, what part of solving a crime normally takes longer?
Sorry, I missed part of that.
Louisa asks, what part of solving a crime normally takes the longest?
Oh, good question. And that probably is entirely dependent on the case itself. If you have a very complex crime scene, it can take a while, and maybe it spans a huge area too. It can take a while to process and work through those different elements. And then when it gets to the lab, it really determines if it's been prioritized, the backlog of samples ahead of those samples to be analyzed, and the types of samples too. So probably if it's going to be held up at any stage, it'll be the crime scene, the laboratory, and then it takes a while also to move through the courts.
Fernanda asks, do lawyers go to the crime scene?
Does who, sorry?
Lawyers.
Oh, lawyers. No, typically not, no. What we're starting to see more of, though, is in the courtroom, we'll see 3D scans, images, models, even some walkthrough simulations of crime scenes. So while the lawyers and the court might not be present at the actual crime scene when it took place, they will see it when it gets to them in the courtroom.
Okay. So we're almost at the end. Is there any last minute questions that anybody wants to ask Dr. Kimberly? No? Well, okay then, Dr. Kimberly, thank you so much for being here today with us. I can tell you that myself and lots of people in our Efígie team were very, very excited to be part of this talk and to hear you talk a little bit about forensic science. So thank you very much.
My pleasure.
So, if you have any last words before I start speaking Portuguese again.
No, my pleasure. It was fantastic. Thanks for having me, and get in touch. Honestly, if you have any questions, I will talk about forensic science with anyone who wants to talk about it with me.
Yeah, everybody here in the chat is saying thank you. They liked it so much. It was awesome. So thank you very much, and I hope you have a good night.
Thank you.
Thank you, Professor Kimberly.
Gente, vai.
Tá bem. Agora, encerrando o mock, só lembrando para todos, por favor, entra lá no nosso Instagram, porque vocês podem ganhar alguns sorteios, alguns brindes legais que vêm das faculdades. E também fica atento para o próximo mock. Lembrando que se alguém participar de mais de 3 mocks numa trilha, vocês vão concorrer ao sorteio no final lá da trilha, tá? Então, todo mundo, boa noite e boa quinta-feira.
Tchau, boa noite.
Thank you.